Love serverless, then travel less, but be boundless for your thirst of knowledge. Catch me this Saturday at OSCONF virtually.
So next session is by Ransi. He's an accomplished software engineer with strong SDLC experience and a string of projects, primarily in the security domain. Ransi strives constantly to build better software with extra focus on data security that would be kept throughout its life cycle and not just an afterthought. Considers himself to be perfectionist yet remains practical, knowing where to draw the line and stop. Runcie advocates strong data privacy and possessing a natural penchant for security. He began working full time on Cloud Brew to minimize data breaches in this mass surveillance world, which continues now as an open source project. Over to you, Ransi. Thank you.
Thank you so much. So let me just start with the presentation. All right. So first of all, thanks for having me. It's a great honor to be presenting at the OSCON. And today I'm going to be touching upon serverless security. And just for the kick, I've actually put the logos of all the three major providers like Lambda, Google Cloud Functions, and the Azure Functions. And what it actually says is uh, just to get started, I mean, this is sort of like my promise to you for the next one, right? So for the next 30 minutes, we're going to be starting with what serverless is. It's going to be defining to get the ball rolling on what the generic cloud security overview is going to be like, provided by all the three providers. Then we're going to be start with the shared responsibility model that's been suited by all the providers. That's sort of like a distribution of security. And then jumping into the meat of the presentation, that is going to be looking at the four scenarios or the use cases that we can actually use to enhance the security of the SaaS offering. All right. So without further ado, let's just jump right into it. And here's just to get the ball rolling. We want to start it off by defining serverless computing. And the definition has been straightforward, picked up from Wikipedia, and all of you can read, and I'm not going to repeat it. So just look at the underlying. So it's sort of like a computing execution model. So it is sort of like a way of executing things, but the only difference is the provider or the cloud provider is dynamically going to manage the resources. And that is sort of like the fundamental shift. And we've had very insightful sessions before where as an ops person, you are in charge, but this is sort of like the no ops world where you are not in charge of the operations, but the cloud provider is sort of like doing it. And what it actually does is you are in charge of now of just the code without the worry of the operations, because the provision and the utilization is done. You can horizontally scale or vertically scale as what you actually want without worrying about the operations and the management, and even provide for sub-second billing. So this is sort of like a fundamental shift from where we come, because this is a paradigm, a whole new paradigm way of looking at things. And this is the abstraction that's being done with serverless. So how did we actually get here? And here what you can see is from the top right is the functions. But before that, we started with the bare metal, and then which evolved into virtual machines. And then sort of like the next evolution came in sort of like the container, right? And when Solomon Hayek announced Docker in 2013, that was sort of like a game changer. But then we have this fact that has been come up as sort of like an abstraction on top of containers, where you are not in charge of the maintenance, and the concerns of maintenance is constantly decreasing as we go right over the x-axis. And then you are constantly increasing on the business logic for doing the thing. And that is where the SaaS is sort of like a game changer. So the question on everyone's mind is, are we like fixing things that doesn't exist, right? And I had to put this slide because the cashless thing is like very relevant over here, but we are not reprinting the currency, no, but more like cashless is sort of like serverless, right? I mean, cashless doesn't mean that there is no cash, it is less cash. So serverless as in also means there are no servers, it's just less servers. So there are still the servers involved, but it's just about the decreasing concern. And this is sort of like the analogy that I want to dive in because for the rest of the session. And it is very true because the serverless is definitely eating the stack. And whether it be like the front end or the back end, there is definitely a constant way of doing things from all the three classic business logic of doing things, right? And serverless is everywhere. So many people confuse themselves as to what serverless is, right? And what a SaaS is. Well, serverless could be anything. AWS S3 bucket is serverless. But SaaS is sort of like the maintenance of the functions that is there. So serverless is sort of like the superset that is there. But SaaS or the functions as a service is sort of like a small offering on top of it. The key management from all the three providers, right? That is serverless. The SQS offering, the queue management, anything that where you are not involved in charge of the maintenance of the resources, all those jobs are serverless. But SaaS is mostly from the function, that is the business logic, a small chunk of code that is ephemeral, and that is the small subset of the serverless offering. So now, let's just shift gears and then to set the context what the cloud security is, right? And just look at the underlying words that are over here. So it is a combination of policy, technology, applications, and the controls that are basically needed to define. It is the all encompassing stuff. And it is not just all of them work in silos, but all of them have to come together to define the cloud security, right? And what it actually means is now it's all the more relevant because the infrastructure and the landscape has undergone a rapid shift. And what it actually means is when I joined the industry, this is sort of like the architecture diagram that the IT person had told you, right? The big bad world of internet stuck behind a firewall and the glass house. We don't know what the glass house is going to be in the future, right? Or everyone connecting from home, right? So sending only the requested information to that and everything else blocked by one single point of contact, that is the firewall, right? And that is the traditional view. But this is sort of like the modern view, right? Everything is on the cloud. You access SaaS, PaaS, PaaS, CaaS, DaaS, whatever apps, right? It's all there. It's all up in the cloud for us to be accessed. Now we are back to the streamlined version of doing things where everything is there up on the cloud. So now, if that is the sort of thing, should the cloud security be a little different? We cannot be stuck with a 1980s view of knuckles and security groups and port blocking for cloud, right? The security also has to be thought differently because it's not the same as a network security. So to understand that, you need to understand the important facets of the cloud because the cloud is ubiquitous. It is everywhere. It is scalable. At the push of a button, you can have any number of cores or processing power or storage or memory at your fingertips, right? It is well integrated. You have an IT infrastructure. It is very well possible to have it integrated with the cloud system. The sort of like the hybrid philosophy of doing things, right? It is comprehensive because it scans every byte, whether it be outgoing or ingoing. It is definitely going to be a very comprehensive thing, even if it is encrypted. And it is intelligent enough. Way back, like in 2007, when AWS launched, it was just the S3 bucket and the SQS. And now, if you look at the AWS console, you need a scroll bar to actually see the list of services, right? So that is the whole intelligence that is kicking in with the demand for the services that is there. So cloud is constantly evolving. So now, earlier, you had the joy of spinning up an EC2 machine and then get your stuff running. And that was like moving fast. And then you put a layer of security on top of it. But now, it's sort of like the and, that is, you need to have the agility and also you need to be secure. And that is sort of like the modern philosophy of doing the mindset. So with that, I'm just going to get into the second part of the session, and that is the core part, where I'm going to begin by doing a comparison of all the three major cloud providers from the security offerings. And we're going to start with the 800-pound gorilla in the room, that is AWS. And as you can see, there are like a lot of security services that are being there, which are being offered. So You have the IAM in terms of the security management. You have the layer 7 protection in terms of WAF. There is a shield in terms of the L4 protection. There is a KMS management. So these are all the fundamental building blocks of cloud security. Now, this is not the whole exhaustive or the comprehensive list, but more from the handpicked ones or the most important ones that I have picked up. And if you go into the GCP, if you go into the GCP, this is sort of like the shift basically is remaining the same in terms of the shielded VMs, that is a hardened operating system. You have the network wrapper in terms of the DCP. You have the L4 and the L7 protection that has been there. You have the hosted IAM providers and the KMS, all the providers that are being there from GCP. And the landscape doesn't change much in terms of the Azure as well. Because so what I want to drive is these are sort of like the fundamental building blocks of cloud security. Earlier it used to be on-premise where you used to be in charge, but now there are managed services which are being offered by all the three providers. So with that context, now let's just understand what the shared responsibility model is, because who doesn't want to be secure in the cloud? And the fundamental understanding behind this is very critical. And there are two things. There is security of the cloud and security in the cloud. And what does it actually mean? So to make sure that the physical security of the data center, the region, or the availability zone, to make sure that the Cat6 cablings are being used to prevent eavesdropping inside the data center. So that is the cloud provider's responsibility. That is security of the cloud. And what is security in the cloud? That is from the customer to make sure that the operating systems are patched. Right? You are making sure that you are only allowing traffic from legitimate IP addresses or ports that are not open to the world, or making sure that your encryption is there at rest or at motion, right? So that is all your responsibility. That is security in the cloud. And this fundamental understanding would basically go a long way in making sure everything is secure when you migrate your workloads to the cloud. So with that, just want to harden or start with the meat of the presentation by the session of hardening the FAS. And just for fun, I've created this very famous diagram of Lambda, AWS Lambda, which is sort of like the king of the hill in terms of FAS, with sort of like a fork and a soup spoon, right? And it's sort of like a 1-star rating right now. And this is the current FAS that is there when you deploy out of the box, whether it be from AWS, GCP, or Azure. So now let's just try to harden it. But before that, we want to understand what serverless looks like inside the VPC. Now, VPC is sort of like the network boundary that is being defined, and it is within. So this analogy of the cave is basically that it starts and it's got an end. But the fundamental thing that is there in terms of a cloud resource, including a FAS, is that everything has to be provisioned within the VPC. So now your security, even though your FAS is ephemeral, is only as good as the security of the network security fabric. Now, what if there is a breach within that SDN fabric? And there are few, right? These are two major vulnerabilities that happened in 2019 for the Azure stack for remote code execution and spoofing vulnerability. All of this affects the stack and also the Azure function. So just because you think that it is an ephemeral function that is there, doesn't mean that it is not vulnerable. It is definitely vulnerable because your weakest link is the SDN fabric or the VPC. So if there is a vulnerability, you are definitely going to be attacked. So now we have to prevent that. And I'm going to stop talking right now. I'm going to show you the code with respect to what it actually means. And since this is sort of like a live demo, I don't want to do like a live coding. So I've just created this sample exploit. What it actually does is it's written in Python so that everyone can read. And we have this functionality that it accepts a PDF and it just do the text mining out of it and then gives you the important relevant keywords for the HR. So this is a functionality, a very common functionality for candidate screening, right? Now, the assumption that we have while the software developer does is the candidate would only provide legitimate PDF files, right? And that is the weakness that is over here, which is you can actually embed all your file names directly into the shell and it is directly executed with a command shell. So now this is like a very poorly written program And that is what I want to emphasize. Now, in a real world, you wouldn't want to call your shell script directly from the command execution. That is like a very bad programming practice. But now this is like a very weak or a very insecure program that I want to dive through. Now, if a candidate provides this PDF file name, right? This is a very valid PDF file name. That is, it's got a foobar, I mean, just something. And then I'm just dumping all the environment variables into a curl and just redirecting it into an attacker website .pdf. So now when this gets uploaded into the task function, all the environment variables within that cloud provider is just going to be redirected into the attacker website. So this is just one thing that I want to show off. And for the sake of everyone, just before the session, I have tweeted the sample exploits and also this whole slide share. So feel free to look it up. That's my Twitter handle. So I just tweeted it just before the session, right? And what I wanted to drive with that earlier context of the insecure program was that it is definitely vulnerable. And this is one of the exploits. So now I have access to the attacker system. And here I have a system in which I can do a subprocess invocation for the Lambda or the Google Cloud function. And what it actually does is, here you're creating a subprocess. So it is very well possible within Python to create a subprocess. So you are just touching it. You are then redirecting the output to a read-only file within the /tmp. That is sort of like a write accessible file system. And then you are redirecting that whole process tree of my Lambda or GCS into that TMP. And now I can just read that /tmp location to get the executing processes that are there within the Lambda or the GCS context, right? So this is one exploit. That is, you can invoke subprocess invocation. Now, the second one is just only relevant to AWS Lambda, and that is you can access the function handler of the serverless function. And now, if you have worked with Lambda earlier, you know that when you upload a Python code, it goes to the /var/task, and it creates this default file name called lambda underscore function, right? So now what I'm going to do is I'm just going to cat that thing, and I'm just going to redirecting it into /tmp, and I'm going to return it as a JSON string. So now, if there is a vulnerability, I would be able to read your whole function source code and get it redirected into your JSON output. And this is like really scary stuff, right? So you make sure that your program is well audited in terms of security, right? So otherwise, don't just think that your SDN wrapper is going to make sure of it. If there's a vulnerability, these are all the stuff that is there, right? So this is the second exploit. Now, let's go into the third exploit. And this is again with respect to accessing the /tmp. Now, I have touched it previously in the first two exploits. And this is again relevant to Lambda and Google Cloud Functions. So what it actually does is you are creating a file dynamically in the /tmp file system, right? And then I should be able to write the contents of the /tmp and just return it back and just read it back. So I will be able to access anything. So I will be able to dump a malicious program into /tmp, which can be executed from the OS system call. So because the attacker has the full level of access whenever that function runs. And now the AWS Lambda has got execution limit of like about 15 minutes or something. So that if it is possible to extend it, you can within that 15 minutes, you can do any sort of malicious things within that cloud account. So this is definitely the stuff that you can actually do with the exploit. So now, with all that, how do we harden it, right? And the technique that we can do in Python is something called the monkey patching, which is sort of like a way of saying that now I have this function, but I want it to be done with something else, right? So it's a dynamic behavior of a piece of code whereby I say that this function is not that, but I want it to be like a custom defined function. And why? Because it is basically used in Python to change the behavior of the model. So now in our case, it is very relevant because we are going to be changing the behavior of certain models. And when do we do it? We extend or modify the behavior of the runtime, or doing the testing of the mock behavior, or to quickly fix the issues if we don't have the resources, right? So now in our case, we are doing it for the first use case. That is, we want to extend or modify the behavior of the runtime, right? So we have certain function calls that are there, and we want to change it within how it's executed within the fast environment, right? So let's just try get into it. So this is a sample patch that I have, and what it does is I'm going to be creating a non-working system to eclipse the existing definition, right? So I've created this new definition called, which basically says that when it is being called, it will give this saying that it is not supported. And I've created this safe system, which is only known to us. So only the programmer would know what the safe system is. Now, if a hacker tries to access into my Lambda function and tries to give the OS.system command, it will never work because it's going to be prompted with the non-working system. And the programmer should only use the safe underscore system. So I have eclipsed the OS.system with the non-working system to give this command custom tracing. And I'm going to be using this new definition for safe system to call all the other safe systems. So with this, we should be able to spot a couple of vulnerabilities that are there. And this example is again with respect to Python. For if you use another runtime like Go or Node.js or any of the other modules which are being supported, there are other techniques that you can actually use to eclipse this behavior. So with that, we have now changed this fast into this. So this is now how your fast looks like. It's got a 5-star rating and it's now got a crowbar in the hand. Still looks like a Lambda though. So that's the stuff that I wanted to drive into it. And with that, I just want to quickly end my session because we are sort of like running out of time, and feel free to reach out to me for any of the questions or anything on my social media handle. Right.
Thank you, Ransi. It was an amazing session on serverless security.